Hello and welcome to my solutions to essentially the last 5 questions of the mock exam. Okay, let's do it. So we've got a parametric integration question here, I think. I think we do end up integrating anyway. It's got a bit of a differentiation and integration. In fact, this is a good example of everything they can ask you to do with a parametric equation. Okay, firstly, they love to start with these kinds of questions where they're like, t is 3. Write down the coordinates of p. Write down. That always implies there's no working required. Well, p is going to be, when t is 3, 27 plus 3 times 3 is 27 plus 9, which is 36. And the y coordinate will be 3 squared, which is 9 times 3, 27. And so you get the answer of 3627. That shouldn't be too bad, because each t value corresponds to a point on the curve. And you just plug the t value in to find where you are on the curve at that value. Okay, the line L is the tangent to C at P. Show that the equation for L is this. Well, we need to use the fact that dx by dt is 3t squared plus 3. dy by dt is 6t. And then we can use the fact that dy by dx is dy by dt divided by dx by dt. And remember, we're dealing with the point P here, which is when t is 3. Yeah, so we're going to plug that in to here, which is going to give me 18, and to here, which is going to give me 3 squared is 9 times 3 is 27 plus 3 is 30. And so the gradient is 6/10, or even 3/5 if you prefer. Okay, that's the gradient of the tangent. That's the one we want. We're not looking for a normal here. So I can just do y minus y1 is m times by x minus x1. Now, what's my y1 here? It's 27. My x1 is 36, because that's the point P. So y minus 27. My m, of course, is 3/5. X minus 36. This is considerably easier than using y equals mx plus c, because now I just times everything by 5. 5 times 27 is 135. Then times the 3m, we get 3x minus 3 times 36 is 108, I think. We'll know if we've got it right, of course, because they told us the answer. Now, they want this as a 0 equals 3x minus 5y. And then if you add 135 onto 108, I think you get, what is that? 10 to 35 is 20, 27. Good, just as I asked for, as required. Yeah. So far, so good. Okay, the line L meets C again at the point Q, using algebra and showing all stages of working, find Q. So we want to find where this line hits this curve again. Now, there's sort of different approaches you could use to do this, but try and use the easiest approach. Yeah, we know we can plug this in here for our x, because we're trying to find where this parametric curve hits this straight line. If I plug the x in terms of t here, the y in terms of t here, I could solve the resulting equation. So I'm going to solve, terrible handwriting, solve 3 times by t cubed plus 3t minus 5 times by 3t squared plus 27 equals 0. Now, I do have an advantage to when I'm normally solving, but I'm just going to write it down first. 3t cubed plus 9t. But I'm going to write down next to minus 15t squared, just to make this easier. Minus 15t squared plus 9t plus 27. And actually, that is all divisible by 3, so let's write that down as t cubed minus 5t squared plus 3t plus 9. That's just good advice. Cancel down and simplify what you're working with. Now, we do actually know a root of this, because t equals 3 should solve it twice. Yeah, we know a repeated root. Basically, t minus 3 is definitely going to be a factor twice on this, because the roots of this are t equals 3 twice and t equals some other number, which looks, I don't know what other number is going to be, but we'll find out in a second. But you can say by inspection, or by just thinking about it, t equals 3 solves this. And check it, yeah? Does this solve this? Am I just lying to you? 27 minus 45 plus 9 plus 9. Well, 27 minus 45 is minus 18. If you add 9 and add 9 again, you get 0. So t minus 3 is a factor. Now we can do our division by inspection. That's the way I prefer to do it. We get t squared there to make the t cubed. That gives us minus 3t squared, but I want minus 5t squared, so this must be minus 2t. That also gives me a plus 6t, but I want plus 3t, so this must be minus 3. And what I like about this method is I can see at the end I've done it right. And so we have t minus 3 multiplied by t squared minus 2t minus 3. And that gives us t minus 3 times by t minus 3 and t plus 1. And so t equals minus 1 must be at q. And we want the coordinates, well, we just need to plug in minus 1 now. And we get minus 1 minus 3, which is minus 4 for x. And we're going to get minus 1 squared is 1 times 3, 3 for y. Does it look right on the diagram? Yes, it does. So it's looking good. Okay, last bit. Using algebraic integration, find the exact area of R. Okay, right, let's do this. Probably best really here to just integrate below the parametric equation from t equals 3 to t equals minus 1. Because we can always, because we know that coordinate and that coordinate, we can always use a formula for the area of a trapezium to work out that. So I'm actually going to use parametric integration, but then I'm going to remind myself that this is, because that's x is 36 and that's x is, what was it, minus 4? Minus 3? Yeah, minus 4. Minus 4 up to 36 is 40, so that's got a base of 40. But first thing I'm going to do is I'm going to integrate parametrically. Yeah, quite stingy the marks in this one. So between 3 and minus 1, now the formula is y dx by dt for parametric integration. Your y is, what was your y? I've forgotten already. 3t squared. And your dx by dt is 3t squared plus 3. And we're going to integrate that with respect to t. This, by the way, is going to find us, can I just dot the area? This area here and here. And then if I just take that away from the trapezium area, I'll have the area R. So that's my plan, if you like. We'll come back to the 40 in a second. Okay, so integrating this, we get between 3 and minus 1, 9t to the 4 plus 3t squared dt. Keep writing down the dt's unless you don't want full marks. Okay, that's 9t to the 5 over 5 plus t cubed between 3 and minus 1. And that comes to 3 to the power of 5, which I think is 2, what is that? 243, I think 81 times 3, 243, times by 9 divided by 5. You know, and actually show yourself plugging this in. So what do we get here? I think we're going to get, I'm going to quickly work out that 3 to the power of 5 times by 9 divided by 5, 2187 over 5, plus 27, minus, okay, that's going to be minus 9 over 5, minus 1. Now you can sling it in a calculator, and I think you get 2616 over 5. Okay, final bit, the area of the trapezium. Well, that's going to be equal to 40 over 2, and that's because this has a width of 40, because that was 36 and that was minus 4. 40 over 2, and then I need that vertical height and that vertical height, so I need the y coordinates 27 and 3. And I'm going to be multiplying by the sum of those. And that gives me 30 times by 20, which is 600. And so the final area of R is 600 minus 2616 over 5, which is 384 over 5. And it's done. That's the exact area of R. Number 11. Okay, people didn't like this one, but I like it. I really do. It's a good one. Notice that's in bold. X is in the thousands. It's really, I've made this mistake a billion times myself. It's in the thousands X. So this is 3.5X and that's 2X, yeah, throughout. That will really help. Notice as well, you don't need to get part A right to get part B right. Yeah, that's an important point. Okay, anyway, in a simple model, the rate of decrease in the number of bees is assumed to be proportional to the square of the number of bees. Well, the number of bees is X, yeah? So dx by dp, that's the rate of decrease. Well, let's just put proportional to the square of the number of bees, yeah? Now, the way you can change that is dx by dt equals kx squared, yeah? Now, I like to put a minus k in here to keep k positive, to remind me that the rate is decreasing. But if you don't do that, you should still be able to get exactly this answer if you're careful. You should be exactly the same answer. Shouldn't be a problem. So you need to start with that, and it would have got you. Let me have a look at the mark scheme. 1 second. How many marks would that have got you? It would have got you 1 mark getting that far. Yeah, and a lot of people weren't getting that far, and that's not that difficult actually. Okay, what we're going to do here, we're going to need to solve this differential equation. Well, you don't actually need separation of variables for this, but a lot of students I think will use separation of variables because it's a differential equation. And I just want to show you, you can still get the question absolutely right if you separate the variables, put the x's on one side and t's on the other. If we integrate that now, that's x to the minus 2, so it integrates to minus x to the minus 1, and the right hand side integrates to minus kt plus c. Now we've got some initial conditions because when x is 3.5, t is 0. And that's because initially the population was 3,500, but that's in thousands. So x is 3.5, t is 0. So here we've got minus 1 over 3.5 equals c. Brilliant. So I now know that minus 1 over x is minus kt minus 1 over 3.5. I think the first thing I'm going to do here is times it all by minus 1. Now the second thing I know is that when t equals 1, because I think t is in weeks, yeah, t weeks, x is 2, because it's in the thousands again. So you get half equals k plus 1 over 3.5. Taking that over there, that's like 7/14, that's like 4/14. And what are we going to get there for? 7/14 minus 4/14, you're going to get k is 3/14. Yeah, do that on a calculator if you don't believe me. And so finally, what do we know? We learn that, okay, so 1 over x equals 3t over 14 plus 1 over 3.5, but that is, of course, 4/14. And so 1 over x is 3t plus 4 over 14. And then the result follows nicely if you take the reciprocal of both sides. There we go. Done. Okay, part B. There are only 500 bees in the colony 2 weeks after monitoring began. Find the value of t. Well, we just need to use this now. So x is 0.5 here, though, remember. Look carefully. Well, I can see now 3t plus 4. I've written it as 3t plus 14 twice. Yeah, look, this is what I tend to do. Make mistakes like that, just silly mistakes. Okay, can you see that 3t plus 4 must be 28? Because 14 divided by 28 is a half. And so 3t plus 14 is 28. So t is going to be 14 over 3. And that is... oh, hang on. If I messed this up. 3t plus 14 is 28. That's good. I like that. I just rushed this. Hang on a second. Yeah, that's going to be 20. Oh, yeah, it's because I'm still writing 14 and not 4. Funny the mistakes you make sometimes, isn't it? So that becomes 24 divided by 3, you get t equals 8. Yeah, I could see, I just glanced at the mark scheme and was like, I'm still getting it wrong. Look at that, I should have a 4 there as well. Yeah, so sorry, I changed a 4 into a 14 because there was a 14 on the bottom. That's like a classic blunder, isn't it?